हेलो 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 गाइस, फिर से स्वागत करते हैं अपनी एक नई लाइव में। और आज की इस लाइव में हम लोग पढ़ने वाले हैं फ्लॉयड वार्शल एल्गोरिदम। डीपी की एक एल्गोरिदम है, जैसा कि तुम देख सकते हो ये पीछे ऊपर मतलब लाइक चल रहा है थंबनेल्स। और लास्ट क्लास में यार हमने पढ़ा था, जस्ट वेट अ मिनट। हाँ, लास्ट क्लास में हमने पढ़ा था मल्टी स्टेज ग्राफ प्रोग्राम के बारे में, ठीक है। तो उसका प्रोग्राम बेसिकली हमने लिखा था और उसके बाद में देखा था कैसे वो वर्क करता है प्रॉपर, लाइक ये एडजेसेंसी मैट्रिक्स वगैरह बना के हमने देखा था। तो आज की इस वीडियो में हम लोग फ्लॉयड वॉर्शल एल्गोरिदम पढ़ने वाले हैं। जैसा कि हमेशा की तरह हो रहा है कि हम लोग लाइक नोट्स भी बनाएंगे साथ साथ में। और अगर आपको ये नोट्स चाहिए तो मुझे कमेंट कर सकते हो, और अगर आपको मेरे से बात करनी है तो यू कैन रीच आउट टू मी ऑन लिंक्डइन एंड इंस्टाग्राम ऑल्सो। आई विल पुट the link in description and please check it out, and also there's link in the like description of the channel itself, so you can go there also for checking out. So without wasting any further time, let's start the intro. Yo, भाई वापस आ गए हैं। हाँ, तो स्टार्ट करते हैं। मैंने जैसा कि देख सकते हो मैंने यहाँ पे एक नया नोट्स बना लिया 4.2, जो कि वीडियो नंबर 4.2 ही है ये सर का। और ये है ऑल पेयर शॉर्टेस्ट पाथ विच इज़ फ्लॉयड वार्शल एल्गोरिदम। सो लेट मी फर्स्ट कंप्लीट दिस डायग्राम, then I'll move on to watching the video and then working together, learning together.
The problem is all pair shortest path. In this video we will look at a problem and we will solve it using dynamic programming approach. Then I'll show you what's the formula, how we get the formula for dynamic programming, and also I will show you a piece of code for solving the problem.
Okay, sir.
So let us start what the problem is. The problem is to find a shortest path between every pair of vertices. Let us say the starting vertex is 1, then I should find out a path from 1 to 2, 1 to 3 and 1 to 4. Then again, selecting 2 as a starting vertex, I should find a shortest path to vertex 1 and 3 and 4. Similarly, from 3 I should find a shortest path from 1, 2 and 4, from 4 to 1 and 2 and 3. So this looks similar to single source shortest path, that is Dijkstra algorithm. But Dijkstra algorithm will find out a shortest path from one of the source vertex. And Dijkstra takes order of n square time. If I run Dijkstra algorithm on all the vertices one by one, that is all n vertices, then I can get the result. Yes, I can use the Dijkstra algorithm for solving this problem for all n vertices one by one, and for each vertex it will take n square time, and the time will be order of n cube. So this problem can be solved using greedy method also. But let's now see how we can apply dynamic programming for solving this problem. Now, how the problem can be solved using dynamic programming? Dynamic programming says that the problem should be solved by taking sequence of decision. In each stage we will take a decision. So what decision I have to take? Let us see. See, if I have to find a shortest path between vertex 1 to 2. So there may be a direct edge path from 1 to 2 also, like here you can see. Or maybe there is a shorter path going via vertex 3. Or it may be going via vertex 4. So in this way I have to check or decide whether a shorter path is going via some other vertex. So I'll start selecting the middle vertex as vertex 1. So I'll find out first whether there is a shorter path between all the pair of vertices going via vertex 1, then via vertex 2, and so on. So this is how we can take decision or sequence of decisions. So how this can be done? This can be done by just preparing matrices. Explaining this adjacency matrix, see here from 1 to 1 or 2 to 2, 4 to 4, there is no edge. That's why all these are zeros. Means there is no edge possible, that loops are not possible. Then there is an edge going from 1 to 2. So 1 to 2, the cost of an edge is 3. And similarly, there is an edge going from 2 to 3. So the cost of an edge is 2. So 2 to 3, the cost of an edge is 2. If there is no edge, from 3 to 2, there is no edge, you see. So 3 to 2 is kept as infinity. In case of absence of any edge, we will take it as infinity. Otherwise, for self loop, we will show them as 0.
0. Okay.
Now, how we will solve this is, we will solve it by preparing matrices. So let us see how matrices can be prepared. Let us prepare a matrix for 1, A1. See, this was A0, original matrix. Now here, I am going to consider the intermediate vertex as vertex 1. So is there any better, shorter path going via vertex 1? So when I say vertex 1, then all the paths that belongs to vertex 1 will remain unchanged. So I should not calculate them. Directly I can take them here. So those values are 0, 3, infinity and 7. And these are 8, 5 and 2. So first row and first column already I have taken as it is. Then what about the diagonals? There are no self loops, so I will fill those diagonals also. Now remaining values I have to find out. What are those? First let us check this one, that is 2 to 3. So how to get this value? How to check whether there is a shorter path via vertex 1 or not? So 2 to 3 I will take A0 of 2 to 3. So what is there in this matrix 2 to 3? So 2 to 3 is a 2. And A0 of, now in between I should include vertex 1. So 2 to 1 and 1 to 3 from those matrices. From that matrix, 2 to 1 and 1 to 3. 2 to 1 is how much? 8. 1 to 3 is infinity. So this is 8 plus infinity. This is infinity only. This is less. So there is no better path via vertex 1. So let it be 2 only. Now I have to find out next one, that is 2 to 4. So A0 of 2 to 4. What is the value there? 2 to 4? 2 to 4 is infinity. This is infinity. Now I should include vertex 1 in between as an intermediate vertex. So A0 of 2 to 1 plus A0 of 1 to 4. So from that matrix find out 2 to 1 and 1 to 4. 2 to 1 is how much? 8. Then 1 to 4 is 7, 15. So this is 8 plus 7. This is 15. So this one is smaller than infinity. So update this path to 15. So this means that from 2 to 4, there is no direct edge path. But 2 to 1, then 1 to 4. That is 8 plus 7, 15. There is a path going via vertex 1. That's what we got the answer here. Now I have to fill up these values, right? So that is 3 to 2. So I'll find out A0 of 3 to. In between I should add 1, 3, 1.
2 to 1 क्या था?
1, 2. So 3 to 2 is how much?
1 to 4.
3 to 2 is infinity. 3, 1, 5 plus 1, 2 is a 3. So you can check there. Here infinity is greater, so this value is smaller, that is 8. So we got a smaller value, 8. In the same way, I should fill up all these values. So I have prepared this matrix which is going via vertex 1. Now I will prepare a matrix which is going via vertex 2. So I should generate this matrix from this matrix. So when I am taking a second matrix 2 as an intermediate vertex, then second row and second column remains as it is. So I will take this second row, second column as it is. 8, 0, 2 and 15. Second column is 3, 0, 8, 8. 3, 0, 8, 8. And the diagonals remains 0 only. Now I have to find out few values here. What are those? First one is 1, 2, 3. Let me find out from this matrix. A1 of 1, comma 3. A1 of 1, comma 3. Here 1, comma 3 is what? Infinity. Then in between I should include vertex 2. So A1 of in between 1 to 3. So 1 to 2 plus A1 of 2 to 3. Check this one. 1 to 2 is 2, 3. And 2 to 3 is 2. So this is 3 plus 2, that is 5. And this is smaller. Update this. Now this was infinity. Now we got a path via vertex 2 in between 1 and 3. So 1 to 3. There is a path going to 2, then 3. So 3 plus 2, 5. We got a path here. So that's it. Now I should get this value 1 to 4. So a1 of 1 comma 4 is how much here? 7. Then in between I should introduce vertex 2. So 1 to 2 plus a1 of 2 to 4. So 1 to 2 is how much? 3 plus 2 to 4 is how much? 15. So this is 18, but this 7 which is already there, which is better, so take this 7. Now in the same way I should fill up all these values. Already I have prepared this vertex 2 as an intermediate vertex. Now I have to find out vertex 3 as intermediate vertex and generate the matrix. When I say 3 as an intermediate vertex, then the third row and third column remains as it is. So this is 5, 8, 0, 1 and this is 5, 2, 0, 7 and the diagonals are 0. A2 of 1 comma 2 and in between I should take intermediate vertex as 3, then A2 of 3 comma 2. So 1 to 2 is there, so in between 3 is there and 3, 1 to 3 and 3 to 2. So out of this, which one is smaller? 1 to 2. 1 to 2 is how much? 3 there. And 1 to 3 is how much? 1 to 3 is 5 plus 3 to 2. 3 to 2 is 8. 5 plus 8, 13. This 3 itself is smaller, so take 3 only. In the same way, I can find out all these values by taking 3 as intermediate vertex. Now I hope you have understood how I am getting the values. So I'll prepare all the matrices. So here are the 4 matrices. Finally, the 4th vertex. When I considered, I got a shortest path between all pair of vertices. So we have taken sequence of decision. In each stage we were getting a matrix here. The table is like a matrix here. And finally, these are the shortest paths between every pair of vertex. What was the formula I was using? I will prepare the formula. Getting the value of any matrix, let us say 4 is the intermediate vertex or 2 is the intermediate vertex. So when I was selecting one of the vertex as the intermediate vertex, then how I was getting the values here? I was getting from the previous matrix. For 4 I was getting from 3, for 3 I got from 2. So how the formula can be framed? So now I will show you the formula. For getting A of I comma j of any intermediate vertex, any value from any intermediate vertex, I was taking minimum of A of I comma j from which matrix? Previous matrix, that is k minus 1. If I am generating kth matrix, then I was taking value from k minus 1. Either this or A of k minus 1 I to k, vertex k, intermediate vertex as k, plus A of k minus 1, then k to j. So here you can see that k is introduced in between and addition is done. So either this one is smaller or this one is smaller. Out of this, whichever one is smaller, I was getting that one. And I was following the same formula for generating all the matrices. I have shown only few terms, that is sufficient for understanding the approach and how the formula is used. See, I have first shown you the working, then I have generated the formula. Right? Instead of following the formula, I have deduced the formula. That's it. Now let me show you how the code looks like if I am writing the code. Now let us look at the code. Every time I was generating the matrix, so how many such matrices I have generated? 4 such matrices I have generated. Right? Now for generating a matrix, what I am supposed to do? I should generate each and every term. So total how many terms are there? See, the number of vertices are 4, so let us say n vertices. So the number of elements are n cross n. This is a square matrix. Now for getting all the elements of a square matrix, I should have two for loops. So I'll take two for loops. For I assigns 1, I less than or equal to n, I plus plus, and for j assign 1, j is less than equal to n, j plus plus, and I should get the terms of a of I comma j as minimum of a of I comma j, that is existing matrix, as it is going to be a single instance of 2D array. In the single instance only I'll be updating the values, so that's why this is the same thing. Then a of I to k plus a of k to j. Out of this I should select any one of them, whichever is minimum. So what is k here? K will be changing the intermediate matrices. So this whole thing will generate just one matrix, and I have to generate all the matrices. So for k assign 1, k is less than equal to n, k plus plus.
ये फिर से समझाइए सर, ये फिर से समझाइए सर.
Any one of them, whichever.
यहाँ पे a of I कॉमा j जो होगा वो होगा मिनिमम ऑफ व्हाट, मिनिमम ऑफ a ऑफ I कॉमा j के, या फिर मिनिमम ऑफ लाइक I कॉमा k के एंड प्लस a ऑफ k कॉमा j के. ठीक है, ये तो समझ में आ गया. आगे बढ़िए. अच्छा, लेकिन ये तो एक ही मैट्रिक्स जनरेट हो रही है ना यहाँ पे, और मुझको कितनी मैट्रिक्स जनरेट करनी है?
Is minimum. So what is k here? K will be changing the intermediate matrices. So this whole thing will generate just one matrix, and I have to generate all the matrices. So for k assign 1, k is less than equal to n, k plus plus. Now first time k will be 1, so the intermediate vertex will be 1 all the time. Then k is 2, so the intermediate vertex will be 2 all the time. So k will take this value. So when k is 1, then the matrix is generated. Then k is 2, then the second matrix is generated. So this is for generating a matrix. That's it. This is the code for all pairs shortest path problem. Then if you look at this code, this is having 3 nested for loops. So the time will be order of n cube. So that's theta of n cube. That's all about this problem.
थीटा ऑफ n
The
क्यूब
problem is matrix.
थीटा ऑफ n क्यूब था आंसर. तो अभी के लिए ये वाली मीट ये वाला मैं ख़त्म करता हूँ. मैं दोबारा से लाइव आता हूँ दूसरी वीडियो के साथ, क्योंकि हर एक लाइव में मैं एक वीडियो कवर करने का सोच रहा हूँ. तो मैं कोशिश कर रहा हूँ, मतलब मैं अभी जस्ट इस लाइव को एंड कर रहा हूँ और मैं फिर से एक नई लाइव स्टार्ट करूँगा अभी ये वाली पूरी वीडियो ख़त्म करने के लिए. ठीक है, तो मिलते हैं नेक्स्ट लाइव में, जो कि अभी है जस्ट. बाय बाय, टाटा. पढ़ते रहो और कंसिस्टेंट रहो. कंसिस्टेंसी इज़ द की. ओके, मिलते हैं. बाय.